Let's practice factoring out negative exponents. Let's say we're asked to factor 6x to the negative 2 minus 2x to the negative 5. Often students pause when there's negative exponents and get a little bit confused. Let's take a minute to make them positive exponents. Make sure we really understand what we're doing when they're positive exponents, and then take that understanding back to dealing with negative exponents. If we have 6x to the positive 2 minus 2x to the positive 5, and we're asked to factor, well, we first look at the coefficients, and between 6 and negative 2, we can factor out a 2. And between x squared and x to the fifth, we pull out x squared because it's smaller than x to the fifth. We're taking out 2 copies of x from x to the fifth. And it doesn't really make sense to take out 5 copies of x if I only have 2 copies to give. So we're going to take out x squared, and in the first term we're going to be left with a 3. 2 divided into 6 is 3. And for the next term we're going to have negative 1. 2 divided into negative 2 is negative 1. And again, if I take out 2 copies of x squared from x to the fifth, I have x cubed left. I have 3 copies left. So essentially what we're doing is we're taking the smaller exponent of the 2 exponents and we're going to subtract it to get our new exponent. We subtracted 2 from 5. We did 5 minus 2. Let's keep that in mind as we go to factor with negative exponents. So again, 6x to the negative 2 minus 2x to the negative 5. With those coefficients in front, we're going to go ahead and still take out a positive 2, and we're going to take out x to the smaller of the 2 exponents. So which number is smaller, or to the left on the number line? That would be negative 5. So I'm going to take out x to the negative 5, and then let's see what's left over. In the first term, I'm going to have a 3 left over when I divide out the 2. And then let's think about what's going to happen to the exponent. So I'm going to have x, and then when I take out negative 5, I'm subtracting it from this exponent. So we're going to have negative 2 minus negative 5. Well, minus a negative is adding, and so we have negative 2 plus 5. So my new exponent there is actually going to be 3, a positive 3. And then in the next term, all I'm going to have left is a negative 1. So we divided out the 2 and we took out x to the negative 5. So we'll have negative 1. And let's just take a moment to think about distributing this back in. So 2 times 3 is 6. X to the negative fifth times x cubed is going to give us x to the negative 2. We add those exponents together. And then 2x to the negative 5 times negative 1 does give us negative 2x to the negative fifth. So this is factoring out 2x to the negative fifth. Now, you might see a more simplified version of this expression written where there's no negative exponent. So just for the sake of practicing, let's do that. So the 2 is going to stay in the numerator because 2 is raised to the first power. It's not attached to this x to the fifth. So 2 will stay up there with 3x cubed minus 1, but x is going to move to the denominator and the exponent will become positive because it moved to the other side of the fraction bar. So this is just, again, a little bit of practice, but this is the correct factorization. Now, could I have taken out x to the negative 2 instead of x to the negative 5? Yes, you can technically factor anything out of anything, but it's going to leave us with negative exponents, and we want to avoid having negative exponents. So this is what we want to factor out here. Now let's factor 8x to the negative 3 minus 12x. So here we're going to go ahead and factor out a 4 from the coefficients. So 4 divides 8 and negative 12. And then from the x variables, we have x to the negative 3 and x to the 1. We're going to take out the smaller of the two, which is x to the negative 3. And then in the first term, we'll be left with just 2. And from the second term, if I divide 4 into 12, I'll be left with 3, so minus 3. And then let's look at what my new exponent is going to be. So when we factor out negative 3, we're subtracting negative 3 from this exponent. So 1 minus negative 3 is going to be 1 plus 3. So my new exponent is 4. And again, we can check by distributing. 4x to the negative 3 times 2 is 8x to the negative 3. And 4x to the negative 3 times negative 3x to the fourth, we'd multiply 4 times negative 3 to get negative 12. And x to the negative 3 times x to the fourth, we add those exponents to get x to the first. So this is the correct factorization again, but if we wanted to avoid having a negative exponent, we would write this as 4 times the quantity 2 minus 3x to the fourth all over x to the positive 3. So we can move the x that's attached to the negative exponent to the other side of the fraction bar to make it positive. Now let's factor 10x to the 1/2 minus 15x to the negative 1/2. Oh no, not only do we have negative exponents involved, we have fractions in our exponents. Still going to work the same way, not too bad. So in the coefficients 10 and negative 15, let's go ahead and factor out a 5. And now for the x variable, if I look at these two exponents, the smaller of the two is negative 1/2. So we're going to go ahead and factor out x to the negative 1/2, and then let's see what's left over. So if I divide 5 from 10, I'm going to have 2 left over, and then I'm going to have x to the 1/2 minus negative 1/2. So remember, we're going to subtract from this exponent. 1/2 minus negative 1/2. Well, that's actually really nice. 1/2 plus 1/2 is just 1. So I really just have 2x left over. And then minus 3, because 5 divides into 15 3 times, and it was subtracting, so minus 3, and we took out x to the negative 1/2. So this is my factorization. One more time, let's go ahead and bring x to the negative 1/2 to the other side of the fraction bar. So we get 5 times the quantity 2x minus 3 all over x to the 1/2. Now let's factor 9x to the negative 1/4 minus 6x to the negative 3/4. We got this. So we're going to factor out a 3 from the coefficients, divides evenly into both. And then we're going to factor out x to the negative 3/4. Negative 3/4 is smaller than negative 1/4. It's further to the left on the number line. So now what we have left in our first term is a 3. 9 divided by 3 is 3. And then in terms of the x variable, we have x to the negative 1/4. And if we factor out negative 3/4, we're going to subtract negative 3/4. Well, remember, we're going to add the opposite there. So negative 1/4 plus 3/4, or 3/4 minus 1/4, is 2/4. And 2 over 4 is 1/2. So my new exponent here for x is positive 1/2. And then minus 2. So 6 divided by 3 is 2, and it was subtraction, and we took out x to the negative 3/4, so this is what we have left. So this is us factoring, and let's rewrite it with all positive exponents. So we have 3 times the quantity 3x to the 1/2 minus 2 all over x to the 3/4. And just as a final note, we usually try to factor because it leads to easier solving. So often this problem might be an equation that we solve, and what we would do first to solve it is factor and rewrite it in this nice form that's factored with no negative exponents. And then if we're trying to figure out where is this equal to 0, then we can simply set the numerator equal to 0. Or where is this expression undefined? Well, then we can set the denominator equal to 0. So factoring is a step in a process. And so we're learning the techniques of factoring, but they are useful as we actually solve equations.